Welcome to Slight Reliability, learning SRE one day at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend. This is the show where we learn about observability and SRE one week at a time. Today on the show, I have Jeff and Ryan from Martens. Welcome to the show. To kick off, we could do a brief introduction to each of you and who you are and what you do. Maybe starting with you, Jeff.
Sure. Yeah, my name's Jeff Martens. I've been working in developer tools, observability, and incident response for 13 years now. I spent some of that time at New Relic, building some new products when they were just a couple hundred person company. And then I had the pleasure to go to PagerDuty and do some of the same things. While I was at PagerDuty, I had a chance to meet Ryan and become friends with him there. And now we work together, which is great. And today I'm the co-founder and CEO of Martens, and we're focused on creating visibility into the cloud products that you build on.
Very cool. And Ryan?
Yeah, so I'm Ryan. I've been a software developer for something like 25 years. Most relevant to this discussion, let's say, I worked at a company called Server Density, and that was my first real foray into infrastructure monitoring offered as a SaaS service. So I worked as a developer there. I spent 7 years at PagerDuty, so I was a software engineer turned product manager at PagerDuty. Did a brief stint for 1 year at NetData, which is another open source infrastructure monitoring tool. And yes, as Jeff said, during my time at PagerDuty, we met and we saw this problem not only at PagerDuty, but I think that was the most recent experience for us. We saw this problem of third-party, cloud dependency downtime as an issue, and we decided to create a company and build a product to help solve that problem.
So, as a general theme today, we're talking about how loosely speaking, I think you put it this way, Jeff, we build software on top of software on top of software. We have more dependencies, particularly in the cloud. And so I guess I was curious, how why is this the case? Why don't we just write software and put it straight on servers like we used to? Well, what's the benefit of having all these third-party dependencies?
Yeah, it's a great question. And, I think the first thing I would say is, some people don't always look at it as a benefit, but I think for the majority of us, we see that it can help us be better at what we do. The most common refrain I hear from what I consider to be some of the most talented and innovative companies is that they want to focus on their core competency and their differentiator, and everything else we should look to the experts to do it. So let's spend our time on the thing we're experts in, and let's let other people spend the time on the things they're experts in. Now, I also think that there's one other benefit of that, and I think users get a huge benefit of that because we have so many different, tools and capabilities that developers can use to build products. It actually results in, this incredible user experience. So, for me personally, I've worked most of my career in B2B software. And in the last 10 years, B2B software is starting to look like, feel like, and behave like consumer software in the sense of how polished it can be, how feature rich it can be, and how quickly, bugs are fixed or capabilities are added. And I think a lot of that is because we're saying look, instead of running this service on my own, like a service to, send authentication emails, or a service to print shipping labels, instead of building that on my own, I'm just going to let the experts do that. I'm going to deliver to my users a better product and a better experience. And at the same time, I can put more of my time into the thing that I'm really good at. And so I think that's a big part of why it's become so common. Of course, there's also a lot of other things to consider, like how complex software has become and what that means if you're gonna build something on your own versus licensing it from someone else. The more complex it is, the easier it is to say, you know what, I'm just going to pay for this from someone else.
Yeah, so I work for Squid Up, and we build visualization, unified dashboarding visualization software. I could see that if you're a developer and you work in this organization, that it's better to be really good at that and to let someone else handle authentication or storage of data and that kind of thing. It kind of makes sense.
I kind of liken it to, as a developer, you have access to all these different libraries or modules or packages, whatever your ecosystem calls them, to do things. If you're doing something that talks to HTTP, you're not going to write that yourself. Probably you're going to choose an HTTP library that's, open source and well documented and that sort of thing. And it kind of has just gone up the stack to, now I'm going to choose a whole service that does this thing or a group of things really well, so I can focus on the core problem that I'm trying to solve with code.
So we build software on like third-party platforms that other people own and operate for us in a way. We also have external dependencies, like you said, for mail servers and all kinds of different things. What challenges does this introduce?
I mean, for me, the first thing that comes to mind is that the developers that are building and operating the software now, they have to become experts in so much more than if they were building it on their own, possibly. So, now you need to support your software and you need to be an expert on your domain, which might include, the services that you and your team own, but also is going to include the services that, other teams in your organization own. And now, oh, by the way, because you're going to go on call for this, you're going to have to know at least a little something, if not a lot, about 40 or 50 other services that your app depends on. And so for me, I think that's the biggest one, is just this challenge of having to become an expert or to have contextual knowledge and awareness of all these things. But so many of them are not inside your four walls. You can't just reach out to the developer next to you to ask about them.
So you didn't have to write the services, but you still have to know enough about the services which you're paying for to sort of operate them. So was it worth it?
Yeah, absolutely.
Exactly.
Yeah, because their reliability is going to impact your reliability. And if you're going on call for this, or if you're having to answer for your company's SLA, frequently, that's going to be impacted by things from outside your four walls. And so, how do you effectively, support that service, and how do you, make sure that you're achieving your, customer-facing SLAs? You're going to have to know how to handle issues when they come up.
Yeah, but everyone knows that cloud services are really stable and you don't have to worry about them. So what's the issue?
Right? That's a funny one. Obviously all of us are laughing. And I think I'm laughing because it's a joke, but it's true, but it's not true, right? If you look at AWS is one of the most reliable, cloud platforms or products in general that I think the world has ever seen. But when it goes down, it is really, really, really painful. And there's no such thing as 100% uptime. And so, suddenly you do have to think about that. I think the other thing that's interesting is if you have your app and it relies on one other app, if you want to deliver 99% uptime, you can just rely on something that delivers 99% uptime. But if your app relies on 40 or 50 other things, and those things could impact your SLA, all of a sudden, if you want to deliver 2 nines, you need to rely on services that have more than 2 nines. And so the margin of error gets so small.
If you have one, so the end to end, if you have one component, like you said, that's 99% available, you get 99%. If you have 2, it's more like 98%. You get to 5, it's around 95%, 10 components, 90%. By the time you get 20 components, which are all 99% available, you actually get about 82% reliability.
Yeah.
Wow.
So, and as I keep saying, it seems like as we go on, software is getting more distributed and complex and more components. So this is a bigger and bigger problem.
Yeah, and I think another problem is that it's not always as straightforward as this product that I rely on is available or it's not available. Oftentimes the issues can be a lot more nuanced than that. It could be, certain functionality and, something's working, but maybe not everything's working. And that makes it a lot more complex when you get paged and you have to respond. The first question is it me or is it them? And, you typically know, I'm pretty sure this is them. It feels like them. But now you have to dig in and say, okay, well, what's happening? Is it the way I've used this service, or is it that service itself is having fundamentally having an outage right now? And is it just one region or is it all regions? Is it some customers or all customers? Is there anything I can do about it, or is there nothing I can do about it? And so you do have a lot of these complex questions that can't necessarily be answered by a bunch of people complaining about an outage on Twitter. That's great. We all knew that AWS was down. But I need to know more than just, oh, there's a problem.
Let's say you do find that there's a third-party dependency which is down. What can you do as a person who depends on that?
It depends, I think, on what the dependency is doing, what you're relying on it for. If, for example, you're an online merchant and your major payment provider goes down, you probably want to switch to a backup. And even knowing, X payment provider is down and switching manually, that's going to save you a lot of money and heartache. We've seen other cases where, say, for example, you're using a third-party tax provider, you simply turn it off. So you're not collecting tax from your customers. You're kind of eating that cost on your own, but at least you're not down, right? So there are things you can do, whether disabling it or switching to a backup. Those are two things that come to mind that we've seen.
What about degraded service? So maybe you've got like some sort of enrichment service, and you can get a fairly accurate calculation for something, but you just turn it off, or you have some other, it goes to some cache instead and gives you a kind of fairly accurate estimate for something, that kind of thing. Have you seen that in play?
I mean, personally, I would just disable it and like turn it off entirely myself. I can't say that I've seen that myself. But, find an alternative or wait till it comes back online, turn it back on.
Sometimes the most simple thing you can do is to reduce the chaos and send people back to work. So we had an example where I've talked to somebody and they had a major outage. 8 different people were paged, jumped on an incident response bridge. Somebody gets on the call and they says, you know what, I've seen this before. This is DNS. And the incident commander said, okay, somebody go check the status page of our DNS provider. They went and they checked the status page. Everything was green. So they came back to the call and they said, well, I checked the status page and everything is green, but it just feels like it's a DNS problem. But without that evidence, the incident commander started looking for other reasons. So they started assigning research tasks to a few other people, like go check this out, go do this. About 25 minutes passed. And finally, the DNS provider updated their status page and they said, hey, we're having a major issue now. And I think about that and I go, well, could they have done something about it? And I think, technically, yes, right? Like you could fail over to another DNS. Now, I don't know if that would be able to be effective in time to really make a difference or not. But at the very least, they could have sent 7 people back, to their desk to work and say, look, it's a DNS outage. We know that's what it is. I don't care what the status page says. We have, a signal of it. And, so in that case, like, I think, being able to have the right level of visibility into your dependencies can at least help you manage things better. But on top of that, I think there's also opportunities like to avoid issues. I've talked to somebody that hooked in monitoring of their cloud platform into their CI/CD pipeline, and their CI/CD pipeline would just automatically pause if there was any hint of a problem with their cloud platform. And they said, look, it's not worth it for us to take this risk of trying to deploy something when, something is not functioning the way it should. And so just out of an abundance of caution, we're going to automatically deploy or pause and restart. But I think the ultimate thing we can do is we can work with vendors that meet our reliability needs. So we can understand what their reliability and uptime is beyond the status page, because I don't think status pages are telling us the full story. But we can also get other information out of that, like what is their disaster recovery plan? Like what cloud and regions do they operate in? And is it the same as mine or is it a different one than mine? Because if it's the same region as me at the same cloud provider, that's introducing risk. Who is my contact there? Will they come to an incident retrospective with me to talk about this, if something does go wrong. And so partnering with our vendors, I think, is a way that we can avoid these issues to begin with. So it's not just incident response. I really think it's about like, how do we select vendors? How do we build a relationship with them that is, mutually beneficial? How do we have the right data we need to understand, the reliability of that service in real time and over time, and how do we make sure that we have a line of communication when stuff does go wrong?
And 2 things come to mind what we just said. The first one is that pretty common that, I don't know, is there any data around status pages and how slow they are to respond to incidents, that kind of thing?
I can share data that we're tracking. I I can't link you to a report of this, but although we probably should be able to do that. But I've been tracking this data with some of the work that Ryan and I are doing. And currently the average that I'm seeing is 25 minutes from when we believe the issue actually started to when the first status page update came. Now, it's an average. Averages, as I'm sure this audience more than anybody knows, averages are a little weird. The median was 17 minutes, I think. So, but it spans anywhere. I think in the data set, the fastest one we saw was about 3 minutes to update, which is mind-blowingly impressive. But I've also seen an hour and 57 minutes on the other end.
Do you think that people naturally have a distrust for status pages because of the experiences that they've had, or do people just put faith in it?
I believe that there's a massive distrust because I've had people tell me that. The thing that I find funny is we still keep looking to them as our source of truth, right? So everyone complains about them, but as soon as something goes wrong, what do? We go to the status page or the personal health dashboard. So I don't know, maybe we're doing it just so we have something else to complain about. But like we all know that they're unreliable, yet we all, including me, go to them whenever we think there's a problem. So to me, it's like a sign that people want communication from their vendors, but it doesn't always happen the way they would like to get it.
I also agree with you. You see, you'd be picky about who you partner with, who are your vendors you pick, and pick them because they are good at communicating, reliable, honest, that kind of thing. A lot of vendors, some vendors, don't even provide SLAs. They refuse to give you a reliability SLA or an availability SLA and that kind of thing. Is that common? Do you think that's a problem that they won't commit to a certain level of reliability?
Yeah, I mean, I think it depends on the type of product it is. I'm never going to say blanketly like it is or it isn't a problem. But if I'm purchasing something that's critical for my business and I'm paying a notable amount of money, it's a big red flag if they say, look, we refuse to commit to anything. Now, SLAs themselves are interesting because they're promises with consequences, but I think rarely do the consequences get applied. And I actually think that's okay, right? Like, I'm not so interested in an SLA credit. Like, okay, so you give me 10% of my monthly spend back. Like, I guess that's nice, but it doesn't change my business at all. What changes my business is if you as a vendor can improve your reliability next quarter or next year, so I don't have to have as much risk on my side. So to me, the SLA is really more around, can we have a conversation about it? And, are you doing what you say you can do for us? That could come from a good relationship. It doesn't necessarily have to be a contractual thing. But I personally would look at it as a massive red flag if somebody refuses.
To me, there's a pretty clear challenge here. We depend on a lot of third parties to provide services that enable us to run our businesses and to provide our customer services. And it's hard to keep track of it all. We can't trust the status pages necessarily. So we kind of want to be accountable and understand exactly what's going on and if there's a problem. So what are people doing? And so maybe I do want to talk a little bit about what Metris does, but let's say someone had never heard of Metris. What are companies doing to keep track of all their third-party dependencies and whether they're up or down? Are they bothering to check?
Yeah, I mean, from my point of view, like there definitely are some that are saying, look, this is important and we need to treat our third-party services just like we treat our internal services. But I also believe it takes a certain level of maturity and like you have to be on a certain portion of your observability journey before you get to that point. And so like some of the most forward-thinking companies are saying, look, like when we create a service directory, we're going to include our third-party dependencies in that service directory, just like we would, a microservice from another team, a couple cubicles away. So I think that's the first thing you can do. When it comes to like getting data, we see a lot of people say, okay, well, most status pages have an RSS feed, so I'm going to plug that into my Slack. I think that's a great first step. Have that visibility. Unfortunately, it's probably going to be 25 minutes delayed, but it's better than nothing at all. I think the most talented organizations are building those relationships, like I was mentioning earlier, is they're getting to know their CSM or their technical account manager. Their service directory has information about who do you contact when there's a problem, where do you go for the documentation, how do you open a support ticket with this vendor, and then they're holding that vendor accountable. They're saying, look, like when we do our a quarterly business review or, the annual review before you ask us to re-sign our contract, we want to have conversations about, your reliability. Like, give us some data that is not just what you put in your status page, because for good reasons, status pages don't have everything on them. And they're asking for data from their vendors so they can have conversations about the same thing. I think the most advanced companies are saying, look, how can we give ourselves visibility? Because as much as we would like to trust our vendors to give us everything we need, the reality is it's probably not going to happen for a lot of reasons, some of them good. Some of them are good reasons why it won't happen. So they're saying, look, we need to take this into our own hands. And they're setting up, it's kind of a funny term, but I hear people call them canaries. Now, it's different than a canary deployment, but they're setting up canaries that are directly observing the most important third parties in their stack, because they're saying, look, I can't trust my vendor to give me everything I need the second I need or want it. And the metrics I get from, my APM solution will tell me something's wrong, but they have a tough time distinguishing between, is it me or is it them? And so they're using, synthetic monitoring techniques to set up, outside in black box testing that can give them a very direct and specific signal about what might be happening, so they can shorten their mean time to resolution, and in some cases, their mean time to detection as well.
Yeah, I was thinking if you were relying purely on passive monitoring, it could be challenging, because you might be an organization which runs some service which doesn't get any load over at night, or it gets very little activity at nighttime, for example. And there's no activity, and you don't notice that actually something's gone down, and it's been down all night, and then it's still down in the morning, and you had an opportunity to get on top of it while it wasn't impacting anyone. But whereas the synthetic transactions provide that continuous feedback.
If I can share an example of how that matters, and it's not just overnight, it can still be at critical times of the day. I know somebody that leads technical operations at a company that provides, online, video conferencing for coaching and mentoring. And, they have patterns where people join video conferences on the hour. But after that, the volume kind of dips off a little bit. And so if you're just using your passive monitoring, you're hoping there's enough transaction volume happening that you can spot issues. But with the direct monitoring that they had against their, video conference API, they were able to see a failure from a test against production before their APM metrics hit that threshold that would require an alert. And so it was probably 5 minutes that they saved, but for some people, that 5 minutes is a massive deal.
We've been talking about synthetic transactions, and I know that Metrist uses them heavily. Can you just give a little bit of a talk about how does Metrist work to keep track of third-party dependencies?
Sure. Yeah. So the goal of Metrist is to empower developers with a similar level of visibility into the third-party services as they have into their first and second-party services. And that's a tall order, and it's going to be many years while we work on that vision, but we truly believe that's what they deserve, because those third parties are just as important as the ones that you build in-house, if not more important. So the way we do that is, the first thing we do is we provide a single place to have the status of all your third parties. Because we know that, the typical digital product is going to use 40 to 50 third-party services, and the typical digital business for everything they do is going to have over 100 of them. Having them all in one place, is one of the first benefits. So we have a dashboard and alerting engine and reporting engine that can cover any third party that you use. The way we do that is out of the box, we support functional transactional testing against 67 popular cloud products. And what we do is we empower users to really simply and easily, run synthetic tests against the services and the accounts of their own that they care about the most. And then the Metrist evaluation engine comes into play and says, look, is this a normal response, or is this something out of normal? And, do we need to alert on it? Is this an incident? How long is it happening? What functionality are we seeing it down? And it does all of that by collecting, the transactional or functional tests.
I'll add to that. In addition to synthetics, we do what we call in-app monitoring as well. So you can install an eBPF filter, essentially, and based on the configuration you provide. So you say, I'm interested in these particular third parties. Our agent will automatically detect that traffic and forward the telemetry to Metris, so that you see a combination of real transactions, like what you would get out of your APM software, as well as the transactional synthetics, and that builds up a nice sort of data source so you can see what's going on.
On the topic of synthetic transactions, like you guys must, pretty used to building a lot of them. I've seen in my time most synthetic transactions I've seen go and hit a homepage, and which to me proves there's really nothing. I posted this morning about it. So it's like there's a house and it's burning down and it's on fire, but the letterbox is looking great. So you're like, letterbox is looking great, house must be fine.
Yeah.
It's hard. I think it can be quite hard to do good synthetic transactions because it involves state and data, and you might be creating things in places in production systems which people don't want you to do.
Yeah.
Any sort of tips or advice? How do you work around that? I'm imagining sometimes you need to work with developers to maybe create special developer endpoints or ways to delete records and stuff like.
On your first point, I mean that's something. It's a very good point. It's not simply about hitting an endpoint and I got a 200 back, yay, everything's fine. You need to actually exercise the system. If a system is creating things, you should create those things and then verify that they got created. The one thing we do to help, we try to be good citizens of these platforms, so we have cleanup jobs that we'll go through. So first of all, if you can delete a thing, we delete the thing. Some other platforms have like permanent deletion, where you delete it. That's like a ghost delete, and then you actually delete it. We also have cleanup jobs that go through and see, is there anything stale in these accounts, clean those up. So that's my best advice, is if you can, clean up. Now, delete jobs probably cause a bunch of problems. If you let things build up and then you delete 100,000 things at once, that's probably going to, from my own experience with other companies, that's going to cause a bad day for someone. So if you just kind of do it, if you have like a user profile or some kind of workload in mind, kind of like mimic that as best you can, so that you're not abusing a system.
I know up until 3 months ago or so, I was working at an insurance company, and they were trying to run synthetics against like core insurance platforms, and it was really tricky because you want to create customers and quotes and policies. In production, it's really hard to get that approved, for one thing, because it also messes up reporting and things if you don't add special flags, which means developers need to develop things to make this possible. It's really not easy to do a good synthetic transaction in some contexts.
Correct. Another example is payment providers. When we do synthetics, it's always in test mode. We're not going to be putting through real dollars. That's where you need to, I think, in cases like that, really rely on your real production APM metrics to see how some providers are doing.
Yeah, I think not everything is well suited for it, but even an example of the payments, like we can't reasonably test processing a credit card in reality, because that would cost money, and you'd have to deal with chargebacks and all that stuff. But what you can do is, like when you look at Stripe, I don't know, they have couple hundred different endpoints. So there is a lot you can do to exercise the system. And so what I always like to think of is like, what is this product meant to do for me? Like, what's its outcome, and how close can I get to making it do that synthetically? Sometimes the answer is you can't. Like for a credit card, actually running a credit card transaction is the thing it's supposed to do. And that is one that I think most of us would be crazy to do synthetically just because of the impact. But can I get really close to that? Can I process intent to charge a credit card, but not actually, have the credit card process go through? Or like, I like to use the example of EC2 because everyone knows it so well, right? Like, don't test that you can use the API to talk to AWS. Don't just test to see if you can spin up an instance with the API. Have a second step that says, okay, my first step tried to spin this up. Now with my second step, I'm going to go see if I can talk to it, because it has to exist for me to be able to talk to it. And that's like the true confirmation that you were able to do something. Now, we might not worry about that too much with something like an EC2. I use it as an example, just because it's so common. But, how can you really understand, like, did it do the thing it exists to do for me?
This reminds me of my performance testing days and running these load tests and hoping to create thousands of customers, going in the database and realizing there's nothing there and being like, I thought I had it, and then having to go and figure it out. Thank you, Jeff and Ryan. This is a great topic. I think it's only going to get more and more important. I think we're going to use more and more third-party services that are just going to spread over both outwards in terms of the services we use and more layers in terms of what we build our software on. So a very important topic and an ongoing challenge. Is there anything else you any tips or advice you could give people out there who are operating and handling incidents in this kind of environment?
Sure. Well, I'll start and say, I agree with you. We're going to keep using more and more third-party cloud dependencies, and I frankly think we should. I think we deliver better software with better functionality, and it's often more reliable than what we can do on our own. But we can't do that blindly, right? Like I do think it's time that we take ownership of the visibility into these third parties, and we can't rely on status pages. I think we've spent enough years proving that they are fraught with issues. And I don't mean that to say that the companies that provide status pages are bad. It's just the concept of using a status page to give developers what they need. I think we've proven it doesn't work. And so now it's time for us to take responsibility of that. And so, my parting advice is to think about your cloud dependencies just like you do the services inside your four walls, and think about the teams that deliver those services to you just like the teams that you work with. Like make them part of your organization, even if they technically aren't, and try to get the visibility into these third-party services that you need, even if you can't, drop your own APM agent into their software.
Related to that, a tip you'll often hear me give, some practical advice. Fire up Excel or Google Sheets or whatever spreadsheet software you like to use, and make a list of all the third parties that your company is using, assuming you don't have one already. Spoiler alert, most people don't have a list of these things. So that can be the SaaS you rely on for productivity, the APIs you're using, your infrastructure cloud providers. Make a list and try to figure out who in your organization was the original person who signed up for that service as well. They may not be at the company anymore, but as sort of like advice number 2, that person's getting emails about important things on that platform that nobody else is getting. So those are 2 things. Yeah, make a list, make a catalog, and try to figure out who was the responsible party for signing up, and go from there.
Awesome. That's all from another episode of Slight Reliability. I'll see you all next week, and hopefully your incidents are painless and your pages stay quiet.